What if we could turn one of the biggest problems of nuclear energy into a solution? Welcome to a discussion on a new generation of nuclear power technology that aims to do just that, turn radioactive waste into a source of energy. The concept is simple. Instead of viewing used fuel as waste, this technology sees it as a resource. It involves repurposing the used fuel to produce additional energy. This isn't just a theoretical idea. Supporters claim that the technology is currently available to resolve the issues with nuclear proliferation that plagued earlier recycling schemes. What's more, they argue that the reactors powered by this recycled fuel would represent a significant advancement in safety. Of course, critics have their doubts, especially given that the nuclear industry is asking the government to foot the bill for constructing the initial plants to showcase this technology. But let's delve into the specifics. Most nuclear power reactors today are powered by uranium and require water for cooling and neutron slowing for successful fission. However, from the early days of nuclear power research, there have been attempts to use uranium and plutonium together to build efficient, fast reactors. In these reactors, the neutrons aren't cooled with water, they remain fast. The goal of the most recent developments in integral fast reactor or IFR technology is to fission the fuel as thoroughly as possible, while generating a significant amount of energy rather than creating new fuel. These reactors wouldn't resemble the massive cement structures that represent nuclear power as it exists today. They would be much smaller with a maximum diameter of 20 feet, and instead of using high-pressure water to regulate the nuclear reaction, they would use a liquid metal like sodium. IFRs would use electricity and a molten salt bath to separate dangerous materials and usable uranium from the waste produced by conventional power plants. The advanced reactor would then be powered by those recovered materials. Naturally, the IFR would generate spent fuel, but the volume of waste would be decreased and its radioactivity significantly lower. IFR waste would need to be stored for a few hundred years, while spent fuel currently needs to be stored for thousands of years. This lower radioactivity means that less space is required to store the spent fuel. Additionally, the IFR includes passive safety features that avert a meltdown in the event of a safety issue within the reactor and don't require operator intervention. In essence, we are looking at a revolutionary technology that could turn one of the biggest problems of nuclear energy into a solution. It's a technology that could redefine the future of power generation, making it safer, more efficient, and more environmentally friendly. In conclusion, this new generation of nuclear power technology aims to repurpose used fuel to produce additional energy, using a concept that is both innovative and potentially transformative for the industry. Despite the doubts and criticisms, it's a step forward that could change the way we view and use nuclear power. If you want to keep up to date and get notified when we release new videos, click on like and subscribe. This helps us keep the channel going and lets us know that you're enjoying our content.
Imagine a world where energy is clean, abundant, and doesn't contribute to global warming. Can nuclear energy be the answer to this? Let's dive into the evolution of the small module technology and its potential to revolutionize the energy sector. The concept of small module technology, such as the Power Reactor Innovative Small Module or PRISM, was introduced to promote a cradle-to-grave approach to the nuclear fuel cycle. This means that reactors could be provided to developing nations and they wouldn't need refueling for 10 to 20 years. This idea was backed by Tom Sanders, the manager of the Global Nuclear Futures Program at Sandia National Laboratories in New Mexico. GE Hitachi Nuclear Energy, a company based in Wilmington, North Carolina, has been working tirelessly to validate this idea. Eric Lowen, their chief consulting engineer for advanced plants, has been traveling across the country advocating for PRISM. His efforts earned him the title of the man who could end global warming from Esquire magazine. However, the journey of transforming this idea into reality hasn't been smooth. The cost of a sodium-cooled fast reactor, an integral part of this technology, is estimated to be 20 to 30% more than standard reactor designs. This has led to calls for the federal government to pave the way for private financing due to the risks associated with cutting-edge technology. Despite the challenges, Lowen remains optimistic. He believes that the Blue Ribbon Commission on America's Nuclear Future, chaired by President Barack Obama, will be supportive. He's also advocating for the government's weapons disposition program to be expanded to include the conversion of weaponry components into fuel. But not everyone shares Lowen's optimism. Critics argue that PRISM and related integral fast reactor concepts are just repackaged, outdated nuclear ideas. They warn the technology is risky, unaffordable, and unlikely to significantly contribute to future electricity production. Renowned nuclear skeptic Amory Lovins cautions that historically, every new reactor design has proven to be more expensive, slower, and more challenging to operate than anticipated. In conclusion, the future of nuclear energy lies in the balance. The potential of small module technology to combat global warming is immense. However, its high cost, safety concerns, and the skepticism surrounding its feasibility remain significant hurdles. The journey of this technology from inception to its current state is a testament to the challenges and opportunities in the pursuit of clean, abundant energy. The question remains, can nuclear energy be the key to a sustainable future? Only time will tell.
If you want to keep up to date and get notified when we release new videos, click on like and subscribe. This helps us keep the channel going and lets us know that you're enjoying our content. Does integral fast reactor technology, or IFR, hold the key to our future energy needs? Or does it pose a dangerous risk we can't afford to take? This is the debate at the heart of nuclear energy discussions. On one side of the coin, we have the International Panel on Fissile Materials, a consortium of experts from 17 nations. Their concerns revolve around the safety and cost-effectiveness of IFR technology, citing incidents of major fires caused by sodium leaks in France and Japan. They also highlight the risk of nuclear proliferation, given that plutonium, a key component of a nuclear weapon, was separated from the radioactive fission products in past fast reactor experiments. This fear led to the cessation of IFR research in the United States in 1994. On the other side, proponents of IFR technology argue that these concerns are based on outdated fast reactor technologies. They claim that the fuel recycling process in IFR technology doesn't require the separation of pure plutonium and doesn't yield plutonium of the chemical purity required for a nuclear weapon. They believe that the technology holds so much promise that it warrants consideration as an energy solution. Yet the only fully functional commercial-sized fast reactor currently exists in Russia. Other nations, including France, Japan, Germany, Italy, and the United Kingdom, have considered fast reactor projects, only to decide against them. However, China and India are constructing advanced reactors that use sodium cooling, albeit with different designs from GE's PRISM, the prototype for IFR technology. So, where does that leave us? According to Albert McKeels, a senior technical executive at the Electric Power Research Institute, the answer isn't clear-cut. While acknowledging that modern nuclear reactors run at over 90% of their potential, making them highly efficient electricity producers, he also points out that significant investment and research would be required to make IFR technology cost-competitive with more established nuclear power technologies. In essence, IFR technology is a double-edged sword. It offers the potential for a sustainable energy solution, but also presents significant risks and challenges. It's a technology that's promising on paper, but without more research, the jury is still out. The debate around IFR technology continues, underscoring the complexity of the issue and the importance of meticulous, thoughtful research in finding sustainable energy solutions. As the discussion evolves, it's clear that the path to our energy future is not a straightforward one, but a winding road filled with potential and pitfalls. If you want to keep up to date and get notified when we release new videos, click on like and subscribe. This helps us keep the channel going and lets us know that you're enjoying our content.